Alright guys, so today we're doing work energy problems. So you're more than welcome to pause the video and attempt the problems by yourself, right? And then check your if ever your solutions are correct. Good. So the question statement reads: the diagram below shows a boy skateboarding on a ramp which is inclined at 20 degrees to the horizontal. Now, a constant frictional force of 50 newtons acts on the skateboard as it moves from P to Q. Right? Consider the boy and the skateboard as a single unit of mass. Right? 60 kilograms. Now, from there on, the first question reads: draw a labeled free body diagram showing all of the forces acting on the boy skateboard unit while moving down the ramp from P to Q, right? So that's right 5.1 here. So I'm going to draw two types of free body diagrams, of which the first one is the common one. Many students love this one, the one that consists of 3 points, and right, it's going to be like this, and this is the FK, right? Good. So this is the FK, this is the normal force, and this is the weight. Now I have to warn you, right? I have to warn you with regards to this one. The problem comes in calculations because some students usually forget that in this instance there's an FG parallel, which is the one responsible for pulling the person down the ramp. But we can't say it's the F applied, right? To prove it, it will take a lot of time. But in this scenario, I want to tell you something. Drawing the components is important, and please, if you can, please do it, right? And this is the normal force which is applied by the surface, and then we have the FG parallel and the FG perpendicular and the FK, right? So we've got all of our components fixed. They're here, and they usually say check your marks. It's an indication of how many forces you need to draw and stuff. Okay, so yeah, we've done that. Now moving to 5.2, it says point P and Q on the ramp are 25 meters apart. Okay, and the skateboarder passes point P and at the speed v initial and passes point Q at a speed of 15 meters per second. Okay, and 5.2 state the work energy theorem in weights. Now, as I say, I do not write definitions here, but then we do usually state it. And the definition for work energy is the total net work done on an object equals the change in kinetic energy of the object, right? That's the answer for 5.2. Moving to 5.3. 5.3, they say use energy principles to calculate the V initial of the skateboarder at point P. Okay, so now to do that, as I always say, I say in all of my videos that the examiner is romantic. If ever he or she asks you a question or a definition above regarding a certain term to define it, that term, it's the one that you're going to apply. And in this instance, he or she said work energy theorem. Now, I know that network is equal to what change in kinetic energy, right? Now, in this instance, now I know I can um, start to deal with this, right? Good. Now, for the forces which are horizontal, which are Fk and Fg parallel, those are the two which are going to be in the network, the total sum of all of the forces, right? So I'm going to say Fk, Fk multiplied by the change in x multiplied by cos theta, which is for the direction, and plus Fg parallel, change in x. Please don't make a mistake of forgetting this. It's a little bit tedious, but then yeah. And cos theta, which is equals to 1 over 2. um i'm gonna write it in this form, right? Vf minus v initial, right? Squared, since it's the velocity is the one that's going to be changing. The mass is just constant, right? Good. Now the Fk, what do I have for the Fk? The Fk, they've told us that it is what? It is 50, right? 50 newtons. So I'm going to say 50 multiplied by the what? By the 25, right? Sorry, 25. And the cos. Now the cos, it's just for direction purposes. Now Fk acts in which direction? The opposite direction, right? So yeah. Now from there on, I can say plus the Fg parallel. Now for the Fg parallel, we have to be a little bit observative. Now here's why. Because since we know that FG parallel is defined as sine, right? We're going to say 60 times 9.8 sine 20. Now don't forget the change in x. Many students do forget that. And multiply by 25 cos 0, which is 1. Now I'm going to write my equal sign below and say equals to 1 over 2 the mass, which is what? Which is 60. Yes, 60. And the velocity is now, the v final is what? The v final is 15 squared minus the v initial squared, right? And from here on we can simplify it. Now let's simplify on this side. So it's going to be 50 times 25 cos 180, which is just going to be negative 1250, so negative 1250, and then 60 times 9.8 times sine 20, right? Sine 20 times 25, right? It's just going to be plus 5027.696, right? And then it's equals to what? To this side I'm gonna have 6750 minus 30 v squared initial. Now after simplification, my vi is going to be 9.95, right, meters per second. So this is my answer for 5.3. Now moving to 5.4. 5.4, they say calculate the average power dissipated by the skateboarder to overcome friction between P and Q. Now here's a tip. Here's a tip for calculating power. Now in order for you to calculate power, you have to know your formulas. Now if you can know all of your formulas, I think you should be good, right? Because in that way you know where you're going. Now there are many, I think it's 2 or 4 or 5 formulas, right? The first one is the F multiplied the V average. The second one is the work over change in T. So the type of power formulas, right? But then I want us to focus on this one, the one that I usually use for all of my problems. My students know it's this one because I feel like it's simple and it's easy, right? Good. Now I'm gonna use this one to calculate the last one, and since I know for my force, they said they want what? The average power dissipated by the skateboarder to overcome the friction force between P and Q. Now since I know what is my friction force is 50, so the force that needs to be overcome, it's what? It's 50. Now we need to know how much power should I add to overcome this 50, and for the V average, we have to find the average between our two velocities, which is 9.95 plus the 15 divided by 2. And then the P average, it's just going to be 623.75 watts. Yeah, simple as that, and just like that, you should be good. So yeah, right. We have reached the end of this video, and if you have any inquiries, you are more than welcome to comment or email me with the email in the description above. And just like that, guys, I'll see you in the next one.